I went to the ESTEC Open Day 2023 and had the unique opportunity to talk again to Dr. Jorge Vago, the project scientist of the Rosalind Franklin rover of the ExoMars mission. Some of you may recall that I also did so last year. As a reminder, the European rover was supposed to leave for Mars in 2022 with the help of Roscosmos, the Russian space agency. After the Russian invasion of Ukraine, this cooperation was halted. It was decided that Europe will proceed without Russia, and all of their contributions will have to be replicated. The new date for the launch is set to be 2028. What has changed since when I talked to Mr. Vago last year? Let's move on to the interview and find out. So hi, I'm here at ESTEC Open Days this year, joined by Dr. Jorge Vago. And could you perhaps first briefly remind us what you do with the ExoMars project?
Well, the ExoMars Rosalind Franklin mission is the new name we have now for the second ExoMars mission. We put a rover on the surface of Mars with a goal to search for signs of life that may have existed on Mars, let's say 4 billion years ago, when Mars was more like Earth, when life appeared here. And we suffered a setback in 2022 because we were going to launch from Baikonur together with our Russian partners. But once the war in Ukraine started, we were ordered to stop the mission and not do the launch. And so the mission is now being formed for a new launch in 2028. Mm-hmm. So since last year, we have dismounted the lander we had. We have taken all the European pieces that we're going to use for the new lander, and we have started to work with industry to set up the contract that will allow us to build a new lander for Rosalind Franklin.
Okay, so those were the major updates from last year. Yeah, so what are the major next steps ahead of us in the progress on this road to launch it in 2028, right?
Yes. Well, now we will have to go through all the normal phases of the project, as you would have. On projects, you have phases B, C, and D. Mm-hmm. Phase B is when you develop prototype. Phase C is when you develop the models that you test in order to qualify your design. And phase D is when you build the actual hardware that will fly. Now, imagine all of this compressed, because we have a lot of stuff that is already built for flight. Mm-hmm. And a few things that we have to build anew. For those things, we find ourselves in a phase B type of stage. But we are, if you like, constrained from the top, because things like the parachutes are already there. Mm-hmm. So the new lander that we build cannot be too different from the old one we had, because otherwise the parachutes would not work. So it's an interesting, I would say it's a new way for us, because it's not a typical mission anymore. So for this year, we are trying to mature the new landing design to what is called a preliminary design review level. Mm-hmm. And so we will sign the contract with industry at the end of 2023, and we will start doing the full implementation in early 2024. It will be slow. It will take about 3 years of industrial work.
Okay, that's very interesting, having this kind of reverse approach. Has this extra time also allowed you to think of those improvements and modifications to the original lander? Are there any new ideas of what can be changed?
Well, some things will change for sure, because in the previous lander we were using Russian descent engines, and we don't have those in Europe. So we have asked NASA if they can give us the descent engines they use for Curiosity and Perseverance. They have said yes, but they are different. So we are adapting the propulsion system for these new engines. On the rover, we're using American radioactive heating units, which are way, way smaller than the Russian ones. So before we had 3 Russian RHUs, which are the size of a small Coke bottle, and now for the same heat, we need 40 American RHUs because they're really, really tiny. And so there will be some changes inside the rover. We're also taking the time to make improvements on the rover electronics. So yes, I mean, we're not sitting idle twiddling our thumbs. We're making good use of the time we have.
Okay, that's great. And another question that I had, I'm not sure to what extent that it's related to the process that will take place during ExoMars, but hopefully you can answer this question. Recently, in the Chandrayaan mission, we heard that the scientists were surprised by how effectively the lunar regolith was absorbing the temperature, right? Does this discovery also translate a bit to Mars, and does it have any impact on the scientific mission?
Well, we have been modeling what happens regarding temperature in the Martian subsurface for many, many years. But the deepest anyone has dug on Mars is about 10, 15 centimeters, which were the Viking landers. So with this rover, we're able to drill down to 2 meters. So if you like, this is new ground. We do have thermocouples on the tip of the rover, so we will be able to tell you how temperature changes with depth. But based on the modeling, this is what we expect. The temperature on Mars varies roughly between 0 to 20 degrees on a hot summer day, and about minus 120 degrees at night. So it's a very big temperature excursion, but not as big as the Moon, because Mars has a thin atmosphere, so it has a bit of thermal inertia. But after you get 50 centimeters into the Martian subsurface, what you get is the average between day and night. So the temperature should be more or less constant and more or less minus 60 degrees.
Okay.
The regolith on Mars, like on the Moon, is the result of billions of years of meteoritic bombardment. So it's porous and it's a very good thermal insulator. But we don't know if it is as good as the lunar one, because the lunar one is dry. And the one on Mars, well, it should be dry, but I don't know if it is as dry as the one on the Moon. So it will be interesting to see that.
That's super exciting. I can't wait to hear what comes next later. And thank you for agreeing to talk to me this year as well. And I hope to catch you at ESTEC Open Day 2024.
I hope so too. Thank you so much.
Thank you very much. Once again, thanks to Dr. Vago for sharing the inside details. If you haven't, check out my conversation with him from the last year. Like and subscribe for more content, and see you later.